Right, let's look at the depth spectra for ethylbenzene, and you'll notice that we have one negative peak on the ethylbenzene and we have a positive peak, and the three peaks in the aromatic range are all positive, and then there was a peak at 144 that's now missing. And so if you compare it to the carbon NMR and think about what we know about depth 135, when a peak is negative, it's a CH2, so automatically now we can assign these peaks on our carbon NMR. So if we flip back to our carbon NMR, and now I can see on my carbon NMR this peak that corresponds to our methylene, our CH2, on our depth spectra is negative. So that was our B, that's our CH2, so that makes, and because it's closer to the aromatic ring, it should be a little bit more downfield. Our A, our CH3, would be the first peak on that depth spectra, so it is pointing upwards, and you can see that it's at 15.8, just like on our carbon NMR, which is around 15.8. So peaks that are positive on the depth spectra, like this is, are either CH3s or CHs, but on the NMR of our ethylbenzene, no alkyl groups have CHs, so immediately we know that's also a CH3, and so we can use our depth to help us figure that out. If I wanted to remove these peaks, here is something that you can do if you go back to your peak picking, and let's say I wanted to start again and just the numbers in myself. What I can do is anytime you see a symbol that looks like the original symbol but with an X through it, that means delete, or I can highlight. So for instance, if I put my number here, I can select your arrow to highlight your peak, and you can just hit delete and it will go away. Let's say because I opened this, the numbers were already there. Now if I put the numbers in, I can see the numbers match with the carbon NMR. One thing you should notice is that around 77, where our chloroform or NMR solvent was, does not show up on the depth, and it's because that sample, the chloroform D, has no hydrogens on it. It is CaCl3D, and so because there's no hydrogens on it, it doesn't show up on the depth either. In our aromatic range, we see that those two tall peaks are positive, and they must be CHs because you can't have CH3s on the aromatic ring because there's a double bond. And we'll also see that your other peak that's a little bit more upfield at around 125, 126 was also a CH. So the one that's missing has to be the one that has no hydrogens on it. And so if we look back at our structure, that must be C. And so because D is closer to the alkyl group, the ethyl group, D must be more downfield, E must be a little bit more upfield, and F is going to be the most upfield. So if we look at our carbon NMR, this is the one that's on the opposite side of the ethyl. And D is the closest to the ethyl, closest carbons to the carbon with the ethyl. E is a little further away, and C is the one directly attached to where the ethyl is, so it should be more downfield. So if we look at our depth spectra, we look at our carbon NMR spectra, should match identically. So when you're reporting your data, all you have to state is whether or not it's a CH2 or CH3/CH, whether the values are up or down. That's the only thing you're really getting from the depth spectra. So it should be the same as your carbon, except for if there's no hydrogens, you won't see a peak. CH2s are going to point downwards, which are negative, and CHs are going to point up. Here's a little tip, however, about our carbon NMRs, particularly for depth spectras. Since we have way less carbons than we have hydrogens, carbon NMR is a little bit harder to pick up signals, and so you'll see actually more noise on a carbon NMR than when you look at the proton NMR. Also, the signals are usually a little bit weaker, sometimes a little harder to scan, especially the carbonyls, which show up over about a 150. So if your sample is very, very dilute, you may not actually see many peaks, and it may be hard to distinguish your peaks from your baseline with all this noise. So you want to make sure that your sample is pretty concentrated. However, on the opposite end, in the depth spectra, if your sample is too concentrated, sometimes the NMR software isn't able to actually phase or accurately process your information, and you may actually see peaks that go in the opposite direction from where they should on the depth. On the carbon, that's not an issue, but on the depth spectra, that is. And sometimes when your sample is way too concentrated, we sometimes see that. If you ever run into an issue where your NMR is either not phased properly, and I'll show you an example of it not being phased properly, or your peaks are possibly pointed in the wrong direction. So if you know that a particular peak at a certain number should be positive and it's not, you can auto phase. So in this area of our, you see something very similar on the other version. We can actually change the phase. And so this is what I mean by your sample's not phased. If you see peaks that look this, where they're partially up and partially down, it's not quite what we expect of our peaks. We say that that's not phased correctly, and so we can use these buttons to help phase you. So you can see here my carbon NMR, I just made peaks that are normally pointed up to point down. So if you look at what's in the top spectra, you'll see that the peaks are pointed down. So I can click on these numbers to try and get them phased the way that I want. So for instance, I can phase a little bit, I can phase a lot, phase very, very, very little with the plus or minus 1, a little bit more with the plus or minus 5, a little bit more with the plus or minus 90. And then you can do that with the bottom part of this as well. So if you ever run into an issue where, let's say, your peaks are not phased properly and you know something should be in a certain direction when it's not, you would just play with these buttons a little bit until you can get it perfectly phased. The other thing, there are all sorts of other tools that you can do in the software. So once you're in the zoom mode, you can do a couple of different things in here, and so you may want to play around. I can increase, I clicked on the little up and down arrow, and I can increase how intense my peaks might be. I can move my spectra in and out just by using these different options that I have available in my window. One thing that you could do if you want to zoom in and do a sort of picture-in-picture spectra is that we can actually go into your little window, click P, and I can zoom in on a particular location and it will make an additional picture of what it is that I'm actually looking at. So I'm going to do that one more time. I'm just going to draw a box over what I want to look at. So when I'm done, what I've originally was looking at, now I can zoom in on this and I can make this a little bigger so that I can see it a little bit more clearly than maybe what I have on the screen. So we can do this over here, for instance, and let's say I want to move that over here, and when it's small like that, I want to show that there's actually several peaks in here, and I want to be able to show that to whoever is looking at it, versus when it's the big spectra, everything's zoomed out. You may not notice that this is actually 2 peaks when you can see that clearly here.